GasPerm 1000 service helps maximize production from unconventional gas reservoirs. The primary goal of fracturing is to create a pathway for hydrocarbons to flow from the reservoir to the wellbore. Recently, we have introduced technology that enables achieving and maintaining a highly conductive fracture for improved long-term production. Through ongoing research, we've also learned how the fracturing process can damage the formation in the vicinity of the fracture face, resulting in reduced gas production and increased water production. When the fracturing fluid initiates and extends the fracture and then carries proppant into the fracture, water is drawn into the formation, sometimes several feet into the rock porosity. This movement of water into the formation is due to the capillary effect. The mineral grains in the formation are randomly sized and shaped. This results in voids or pores between the grains. These pores act just like a straw or a capillary tube, but on a microscopic scale. When fluids flow into the pore spaces, they are held there by capillary pressure and surface tension, and can block formation gases from passing into the wellbore. Here is an actual video of fluid trapped in the porosity of formation rock. The fluid is under pressure, but the capillary pressure exceeds the pumping pressure. It's clear that not much gas will be able to flow through this porosity. This is even more pronounced in unconventional gas reservoirs, where the lower permeability results in increased capillary pressure. How serious is the problem? Water imbibed into the formation matrix can result in greatly decreased gas production and increased water production. Here is a mathematical simulation of water saturation in a non-damaged formation. Note that during 30 days of production, water saturation decreased dramatically, gas production was high, and water production was low. Here's a simulation of water saturation with 99% damage. Note that during 30 days of production, gas production was low and water production was high. Water saturation remained at almost 100% along a large portion of the fracture. The conclusion is that if the reservoir adjacent to the fracture face is filled with water, gas production will be greatly reduced and water production will be enhanced. It's clear that to maximize gas production, the water needs to be removed from the fracture face region. Unfortunately, reservoir pressure and ultra-low permeability formations usually is not sufficient. This microscopic video shows phase trapping, in which water and condensate phases are trapped in this poor network. Even with pressure applied, the imbibed water and gas bubbles cannot be removed. The combination of surface tension and capillary pressure is just too much for the formation pressure to overcome. So, what's the answer? New GasPerm 1000 agent is an environmentally acceptable microemulsion surfactant that can be an effective aid in removing imbibed liquids and enhancing gas permeability in the near fracture face region. This microscopic video was taken under the same conditions as the previous video, but with GasPerm 1000 additive applied. Note that the water in previously trapped phases pass easily through the porosity, leaving a clear pathway for gas production. How well does GasPerm 1000 service work? In East Texas, a Cotton Valley tight gas sand well was fracture simulated using Halliburton's suite of products designed to help improve water frac results. The GasPerm 1000 service included a version of Sand Wedge Enhancer, especially formulated for water fracs, and OptiClean WF agent. Results? Over 14 times the wellhead pressure and almost twice the initial production compared to a conventionally treated offset well. GasPerm 1000 service paid off for another operator producing from a tight gas sand formation in the Rockies. The added value of the cumulative production for the first 10 months using $5 gas is approximately $41,600. And this is for 14 GasPerm 1000 service treated wells and 33 wells using conventional surfactants. All wells produced from the same formation, and all completions were identical slick water designs with the same or similar proppant. GasPerm 1000 service helps reduce damage due to phase trapping, enhances mobilization of liquid hydrocarbons including condensate, helps increase regained permeability to gas following treatment, improves load recovery, replaces methanol for water block applications, improves environmental and safety performance over existing alternatives. GasPerm 1000 service helps maximize production from unconventional gas reservoirs. For more information about Halliburton's GasPerm 1000 service, contact your local Halliburton representative or email stimulation@halliburton.com.